welcome to True Projects. In this video, we are going to explain about the project, which is an intelligent thyroid diagnosis system utilizing multiple ensemble and explainable algorithms with medical supported attributes. So, before getting into the execution, first let's understand what is the project about. So, what is this thyroid disease? First, we need to understand that and how it is caused. In the neck, we will be having a thyroid gland that plays an important role in the bodies. So, it produces hormones that helps to mitigate the things like metabolism, which means how our body uses the energy. Now, when the thyroid isn't working properly and doesn't make enough of these hormones, it can lead to thyroid disease. So this is a condition that will cause all sort of symptoms like feeling constantly tired, gaining weight even if you are eating normally and also having a rapid heartbeat. It's surprising, right? But this problem it affects a lot. It affects a lot of people around 3.7% in the US and 3.5% in the Europe. And what's worrying thing is that number of cases is increasing every year. That's why diagnosing it early is so important. But the issue is that traditional methods for figuring out if someone has thyroid disease can be slow and also complicated. And sometimes they aren't very accurate. It's like trying to solve a puzzle with pieces missing. It's like it takes a lot of time. And even then, you might not get a full picture. So, diagnosing the disease can be quite tricky. Traditional tests they often take a long time and they can sometimes give inaccurate results, which isn't ideal when you are trying to catch a healthy tissue early. On the top of that, when we look at AI based systems, they are designed to help with the detection. They come with their own set of challenges. So, for instance, AI isn't good at selecting the right features from the data. It can lead to poor predictions. So, but the problem in the AI is it cannot select the important features properly. Additionally, many of these systems they rely on data sets that aren't well balanced. So they also have the issue of data imbalance, meaning some conditions are overrepresented while the others are unrepresented. This can create bias in the models, leading to skewed results. So it is really important to tackle these issues head on if we want to improve how accurately and reliably we can detect the thyroid disease. So, to tackle the difficulties in detecting thyroid disease, we are incorporating machine learning based prediction system that aims to boost the accuracy and also the efficiency. So, first, what we do is we have to deal with the sheer amount of data. So, what we have done is we have incorporated three feature selection techniques that is, feature selection, feature importance score, information gain selection, and lasso. So, this helps us to focus on the most relevant features while also keeping in the mind high risk factors identified from the medical references. Now we bring two sophisticated models that are three-stage hybrid classifier and three-stage hybrid artificial neural networks. So these models are designed to enhance how accurately we can classify the data. That is how accurately we classify the thyroid disease. Moving on to improve the performance further as an extension, we have incorporated another ensemble based model that is voting classifier. So, here we have decided to use an ensemble model to make our predictions even more reliable and accurate. What this means is that we have combined the results of multiple models together, that is to get a stronger overall prediction. For this, we have implemented voting classifier that brings together three different models. One is ADA boost, decision tree, and extra tree. This combination actually gives us the best accuracy. It has given the best accuracy, which is great for our goals. On top of that, we also have created a user-friendly front-end using Flash framework. So this interface allows users to interact with the system easily and help us with the user testing. We made sure to include authentication features as well, so users can access the system securely, which is really important for protecting their data and maintaining privacy. Moving on, these are the steps that we have followed to implement the project. So, what we have done is first we have imported the packages and then we have explored the data set to understand the structure of the data. Then we have processed the data using some techniques. We have dropped null values, we dropped unwanted, irrelevant columns, and then we visualize the data using correlation matrix, which shows the correlation between the variables. And then we showed the distribution of the target variable using the sample outcome graph, and then we converted all the categorical data into numerical call numerical data using label encoding. Then we appended all the features to X variable and target to Y variable. And we have selected features using lasso, feature importance, score, information gain, and HRF. Then we split the data into training and test sets. Training is used for training the models, and testing is to evaluate the models. Coming to building, then we initiate the models. That means we will initiate the algorithms, and all the algorithms they will be trained on each individual feature selection technique. That means the data set, I mean the features extracted from all these individual feature selection techniques, they will be trained with the all the models. After training, then we compare them using all the error metrics. After comparing with the error metrics, that means after evaluating with the error metrics, then we will be comparing through graphs. And also we have developed front end using Flask framework, which is integrated with the SQLite, the database. And in the front end users, they will be able to give the feature values. That feature values will be pre-processed at the back end, and it will be fit with the trained model, trained machine learning model, and the final outcome will be displayed to front end, whether the person has thyroid disease or not. Moving on to the algorithms used in the project. So we have implemented all these algorithms. So we have implemented random forest, decision tree, gradient boosting, ADA boosting, first SHE, which is voting classifier, combination of random forest, decision tree, gradient boosting with the soft voting mechanism. And coming to second SHE, we have implemented bagging with random forest. Third SHC is the combination of random forest, decision tree, gradient boosting, ADA boost with the light GBM in the stacking classifier. Then we have implemented 3SHANN, which is nothing but it is the hybrid artificial neural network with the three layers. And the extension model, voting classifier, which is a combination of boosted decision tree and the extra tree. So this model has achieved the highest accuracy. So we have deployed it in the front end to detect the thyroid disease. To implement this project, we need some basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the code folder. So these are the source code files in the code folder of a project. Let's understand each of them. How will they be used in the project? So in this archive folder, we have the data set. So this is the data set that is used in the project. So these are the attributes used to detect the thyroid disease. So this data set will be pre-processed and then we'll be extracting features. That means we'll be selecting important features from that and then we will be predicting. Let's close this, get back. And here in this models folder, we have the algorithm information and that will be loaded into the project code during the runtime of the application. And in the static folder, we have CSS, JavaScript, and Bootstrap files. These are important for the visual appeal of the project. So coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Coming to this notebook file, this is the Jupyter notebook file, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in the individual cells, which makes it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. And here we have two sample files. So let's open the sample AR, sample all fs. So let's open it. This will be having the test cases to predict it in the front end, to predict the thyroid disease in the front end. So we'll be using all this inputs. So these are all the features that are used to predict the thyroid disease. And here in this file, we have the extracted features using the information gain feature selection technique. So let's open this. So these are the features extracted using the information gain selection technique. So these are the features selected using information gain. So we will be using these test cases to predict the thyroid in the front end. Let's close this. Now copy the path of the code folder from the address bar of the file explorer. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. Here, if you observe, current directory is changed to the code folders path. Now we have to compile app.py. So give the command python space app.py and click on enter. This command, it will execute the code and check for the runtime errors, check for the syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google web browser, so I'm opening that. Paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now let's click on register. So click on register. If you are registering newly, fill in all these details and get registered. If you have already registered, you can directly sign in. I have already registered, so I'll directly sign in. So click on sign in. Give your username and the password. So I'm giving my username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. Now we will be doing prediction for the features which are not selected. I mean, we will be doing predictions for all the features and then we will be doing predictions for the selected features. So let's do prediction for the all features first. So click on that. So here we have parameters, right? Let's understand them first. So the first one we have is the age of the person, gender of the person. The next we have is on thyroxine. This indicates whether the patient is currently taking thyroxine, that is a hormone replacement therapy for hypothyroidism. Next we have is query on thyroxine. It's a question about whether the patient has been prescribed thyroxine in the past. Next one is on anti-thyroid medication. It indicates if a patient is currently taking medication to reduce thyroid hormone production. Next one is sick. It's a general indication of the patient's overall health status or presence of the other illness. Coming to pregnant, it indicates whether the patient is currently pregnant as a pregnancy can affect thyroid function. The next one is thyroid surgery. It indicates if a patient has had any previous surgical procedures involved in the thyroid gland. Coming to I-131 treatment, it indicates whether the patient has undergone treatment with the radioactive iodine, that is I-131, commonly used for hypothyroidism. Next one is query hypothyroid. It is a question regarding whether the patient has been experienced symptoms or been diagnosed with hypothyroidism. Next one is query hyperthyroid. It's a question regarding whether patient has experienced symptoms or been diagnosed with hyperthyroidism. Coming to lithium, it indicates if a patient is taking lithium, a medication that can affect thyroid function. The next one is goiter. It indicates the presence of a goiter, which is enlargement of the thyroid gland, often associated with the thyroid dysfunction. Coming to tumor, this indicates if there is a known tumor in the thyroid or elsewhere that could affect thyroid function. The next one is hypopituitary. This indicates if a patient has a condition affecting the pituitary gland that may influence thyroid hormone production. The next one is psych. This indicates if the patient has any psychiatric conditions which can sometimes be related to thyroid issues. Coming to TSH measured, this indicates whether the thyroid stimulating hormone, that is TSH level, has been measured in the patient. Coming to TSH, it is the measured level of TSH which helps to evaluate the thyroid function. Coming to T3 measured, it indicates whether tridothyronine, that is T3 level, has been measured in the patient. Coming to T3, it is a measured level of T3, an important thyroid hormone that affects the metabolism. Coming to TT4 measured, so coming to TT4 measured, it indicates whether the total thyroxine level has been measured in the patient or not. TT4, it is the measured level of TT4 which reflects the total amount of thyroxine in the bloodstream. Coming to T4U measured, it indicates whether the free thyroxine index has been measured in the patient or not. Coming to T4U, it indicates whether the free this is the calculated level of T4U which helps to assess the availability of thyroxine to tissues. Coming to FTI measured, this indicates whether the free thyroxine index has been measured in the patient. Coming to FTI, it is the measured level of FTI, which indicates the free thyroxine available for the tissue. The next one we have is TBG measured. This indicates whether thyroid binding globulin, that is TBG levels, have been measured in the patient. The last one we have is referral source. It is the source or the reason for the patient's referral, which can provide context for their thyroid evaluation. We have understood all the parameters. Let's enter them. Let's give inputs to these. So we have to open the sample file for that. So let's open the sample file of all features. So these are the test cases that we'll be using for detecting the thyroid disease. First, let's try with the first test case. So let's give the age of the person. So age of the person is 75 and the gender is male. And the next one we have is on thyroxine, that is 0. Next one, query thyroxine is also 0. On and antithyroid medication is also 0. And the next one, sick, is also 0. Pregnant value is also 0. Thyroid surgery is 0. So moving on, thyroid surgery, after thyroid surgery. 131 treatment is 0. Query hypothyroid is 0. Query hyperthyroid is 0. Lithium is 0. Goitude is 0. And tumor value is also 0. Coming to hypopituitary, we also have hypopituitary as 0. Psych value is 0. TSH measured is 1. TSH value is 0.6. T3 measured is 1. T3 is 1.8. TT4 is 1. TT4 measured is 1 and TT4 value is 99. T4U is 1. And after that we have T4U, that is 1.03, and FTI measured is 1. FTI is 96. TBG measured is 0. Referral source is 3. Now let's click on predict. So this input will be pre-processed at the backend and then we will be getting the prediction. So here we got the prediction that patient is not suffering from any thyroid disease and he is completely normal. So the application is predicting that patient is not having any thyroid disease. Let's try with the other test case. So click on all features again. So let's try with the 13th test case. So the age of the person is 87. Gender is male. On thyroxine is 0. Query on thyroxine is also 0. On antithyroid thyroxine is 0. Sick value is also 0. Pregnant is 0. Thyroid surgery is 0. 131 treatment is 0. Query hypothyroid is also 0. And next we have is query hyperthyroid, that is 0. Lithium is 0. Goiter is 0. Tumor is 0. Hypopituitary value is 0. Psych is 0. TSH measured is 1. TSH is 0.15. T3 measured is 1. And if we move on, TSH, T3 measured we have is 1. T3 value is 1.7. TT4 measured is 1. TT4 is 162. T4U is 1. T4 measured is 1 and T4U is 0.87. FTI measured is 1 and the FTI value would be 186. TBG measured is 0 and referral code is 3. Let's click on predict. So here we got the prediction that patient is suffering from the thyroid disease. So here we did the prediction for all the features. Now we will do prediction only for the selected features using information gain. So click on reduced features. So here are the selected features. So let's give inputs to these. So we have that in sample IGFS file. So let's try with the first test case where the age of the person is 75, on thyroxine is 0, on antithyroxine is 0, sick is also 0, T3 is 1.8, TT4 is 99, T4 is 1.03, referral source is 3. Now click on predict. So here we got the prediction that patient is normal. He's not suffering from any thyroid disease. Let's try with this 14th case. So age of the person is 64. On thyroxine is 0. On antithyroxine is 0. On antithyroid medication, that is sick, is also 0. T3 value is 0.7. TT4 is 91. T4U is 0.83. Referral source is 3. Now click on predict. So here we got the prediction that patient is suffering from the thyroid disease. In this way, by giving the input to the given parameters for the selected features, we will be getting the prediction whether the patient has thyroid disease or not. Let's check with the graph. So click on graph. So here we have graphs. So this is a sample outcome graph where on x-axis we have the class distribution, that is the target class, and on y-axis we have the count of each class. Here negative means person has no thyroid and sick means person is suffering from the thyroid. So sick means patient is having the thyroid. And this is the correlation matrix. This shows the correlation between the variables. And here we have accuracy score graph where on x-axis we have accuracy and on y-axis we have algorithm names. So here, if you observe, extension is having the highest accuracy. So this is the accuracy graph for all the features. This is not for the selected features. Okay. And here we have precision score comparison graph. This is FN score, AUC, recall score. And here we have features selected for the lasso. I mean, here we have built the algorithms on the features selected using lasso feature selection technique. Here, if you observe, extension is only having the highest accuracy. So here we have precision, FN score, AUC, recall, and here we have feature selection using feature importance selection technique. And all the algorithms are built on this FIS technique. And this is the precision, recall, AUC, recall score. And here we have for information gain system. And here we have for HRFS feature selection technique. Now click on logout. In this way, by using feature selection techniques and the machine learning models, we will be able to correctly predict the thyroid disease. And by this, doctors and also the patients, they can take the diagnosis in the early stages itself. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.